Hey, welcome. So in this course, we're going to be going through this book and translating it into Godot 4. So the goal here is primarily to learn how to use Godot 4 and not necessarily to get into all the nitty-gritty math that this book has, although we will certainly be visiting some of it if you do want to learn the vector math and some of these algorithms a little more in depth. I just highly recommend getting the book or checking out his online class. For this, we're going to be using it the Godot 4 way. So we are going to be using a lot of built-in methods and stuff for dealing with vector math. And we may not always go into exactly what's going on, although I'll try to give you some background so you know. I'm assuming you have Godot 4 specifically. If you're using something before Godot 4, then you're not going to be able to follow along because there's been pretty major changes to the way GDScript works. We're going to start off opening up our project. You get the project manager, new project, and I'm going to put it where I want it. There. The nature of Godot 4. And that just looks great to me. All right, so the book starts off with a very simple concept called a random walker. So this guy can walk around the screen in random directions. So it should be pretty simple to do. We're going to create a root node. In this case, we're kind of using it as the whole game, so it doesn't matter too much what you pick here. I'm going to do, user interface. Doesn't matter, a control node. So the first thing I like to do is go to project settings, and I'm going to up this to, this is resizable. So, do whatever you want here, but I like to have the window a little bigger. And you can see, if you zoom in, she's in the mouse wheel, this faint blue outline. Hopefully you can see that. That's going to be where the initial screen is. Don't worry about it too much. You can set up cameras and move this and everything, of course. But for now, that's our screen space. The first thing we're going to do is click up here on the tree. Click the root node and click this plus button to add a child. I'm going to add a character body 2D. We really could use quite a number of things for what we're doing here, but let's just say it's a character body 2D. Maybe later we'll give it a character controller. For now, though, it's missing some things. It doesn't have a shape. It also doesn't have a sprite. So we're going to add another node. You can right click this, or you can click the plus, whatever you want to do. Add child node, and we need a sprite 2D and a collision shape 2D. So this works with the physics engine. So Godot knows what kind of collision this has, and it can work with the others. We're not going to use it in this lesson, just a good practice to have it on your character bodies. So for a sprite right now, we have the starter icon that every project comes with, and we're just going to use that as the texture. These are our nodes. This is the inspector, very important window, and it has all of these variables in it: position, rotation, scale, everything. This is where everything lives visually, and we want to pick a texture. So we click the box. You can make a texture here, but we're going to quick load. And that's the only one in our project, the only image. So bam, look, now we have a little texture for our random walker. Speaking of which, I'm going to double click that and I'm going to rename that to walker. The collision shape, as you can see, there's an error. There's no shape on this now. So we go over to the inspector. We add a shape. And I think this looks the most like a square or a rectangle. So we're going to add a rectangle shape. And then to adjust that, we're going to zoom in, zoom in, zoom in. You can see the shape here. And we're just going to drag it so that it matches the sprite roughly. Like I said, we're not using it for this lesson, so it's not that important. But I want to show you. But I want to show you how to properly set up a thing. So there we go. And now we're going to want to move our walker kind of into the middle of the screen to start. And sometimes if you move things in Godot, it'll click the stuff that's in the front. So you can see it's clicking the sprite and then the walker as this root. So Control Z, get rid of all that, put it back. If you want to make sure to move whatever you have selected, you got to go to the move mode up here. You can click W also. And now you'll move the whole thing. So we're just going to kind of center that in the screen. And if we click play up here, I'm going to click play scene instead of play game. It's going to ask to save the scene. And let's just call it intro. Or let's call it random walker. Doesn't really matter. And look, you made something on the screen. Go you. I will say, unlike in Unity, you can still edit stuff while it's playing, and it will save it. So, for instance, you can turn off the walker visibility, and it's gone real time. So that can make it really nice to edit while you're playing. But you do have to be careful because when I stop playing, this does not revert. Okay, so now we have a walker. We have a character. We're going to want to put a script on it so that it can do things. First thing we needed to do is take a coin flip and either walk left or walk right. So we add a script, this little scroll icon that here, or you can right click and click attach script this way. You can leave all this. We are not going to use a template. So this will actually give you, this is new in Godot 4, but it will kind of set you up with a basic character controller just right out of the box. But we're going to make things complicated, not do that. We're just going to go no default. We're going to call the script walker. That sounds great to me. You could call it like random walker or something. It doesn't really matter. Name it whatever you want. Name it Timothy. Great. And then the first thing I'm going to do, I like to put these at the very top. So in the book, it defines a class. So in a lot of programming languages, you have to define a class to make the object, like in Unity, for instance. And you don't have to do that here. It is optional, but it can help later in the script with typing things and checking to make sure it's the right class and stuff like that. So it can help to add a class name, and we're going to do that. So I'm going to name it. I'm actually make the class, and it doesn't. Okay. And I'm going to just name it Walker. It's a random walker now, but maybe we'll change it to be controllable. Obviously, you can make it do a bunch of things. So here are two special functions. There's a couple that you can define in your object. The ready, this is going to be called exactly once when the node comes into the scene. So in this case, when you start the game, it's gonna call this, and then it's going to call the process function every single frame. Pass just means do nothing. And if you remove pass here, then it doesn't know that the function is done. And so you're going to get an error. So you have to have it do something. The function has to do something. And in this case, we're telling it that something is nothing. So it just does nothing at the beginning, then it does nothing at the end. So what do we want it to do, though? We want it to walk left or walk right. So let's define a new function. Func step. That's how you do function. And then this little arrow here, which is a dash and a right caret. Void. So this is the return type. This is optional, but it will speed up your code. So it's a good practice to do. But if it freaks you out and you don't know what to do with this, you can just not use it and everything will work perfectly fine, especially for this small project. So void just means it returns nothing. So this function is not going to give anything back. And then enter you have to make sure to indent and you're good to go. So the first thing we wanted to do is we wanted to define a variable. So the first thing we want to do is define a variable that will give us a coin flip, basically, right? So we want it to be random. So we're going to go var random I. Oh, let's call it something better. Let's call it var choice colon. And this is where you put the type. So you could put like bool, which is true, false, int, which is 0, 1, 2, 3, 4, 5, or negative 1, 2, 3, etc. Whole numbers. Float is going to be decimal, like any amount of that. And there's others. Also, if you ever have a question about what something does in Godot, you can highlight it, click Control, and bam, you got the documentation right there. You can see all the things it does. And you can kind of click through to see other things, and it will keep it open here. I use it constantly. So in this case, we're going to use an int, and we're going to say rand I, and just click enter so it fills these in. And that's going to give us a random integer from any whole number. And we're going to, and again, if you want to see how it works, you can click here and it will tell you. So it gives you a random integer, positive integer between 0 and 2 to the 32 minus 1. Okay, well, that's great. We just need random integer modulo what? 2. And what does this do? Explanation here. Okay, so we have two. We want two outcomes. So we're going to do modulo 2. So that's going to give us either 0 to 1. So choice is either going to be 0 or choice is either going or choice is going to be 1. So then let's just do something really simple. We'll do an if choice is 0. So you need 2 equals here. 1 equal makes it 0. 2 equals checks to see if it is 0. Colon, enter with the indentation. So if choice is 0, if this turns out to be 0, then we're going to go, let's say, left. So how do we do that? Well, in the book, it talks about needing to keep track of the X and Y coordinates, right? Where it is on the screen. So right now we just need the X, right? So to go left, we're just going to subtract something from the X. So these variables are already stored. You could define them in here, but they're already in here because we have a character 2D and they're in position dot X. And that's going to equal itself minus 1. You don't need semicolons or anything. Enter, and then else colon. So choice equals, or sorry. Then here we're going to go else, or if you want to be a little more specific, you go elif, which just means else if choice equals 1, because that's the other option. Position.x equals position.x plus 1. Control S to save. You need to make sure to save it or it will not show up in the script. And it will have a little star right here if it's not saved. So now we play and nothing happens. Why? Well, this is never being called right now. Well, we want it to be called, so let's do it real simple in the process function. So in the process function, we call it step. And now nothing happens, but you click Control S to save it. And bang, look at this. It's going left or right. It's just jiggling. He's jiggling. It's going randomly left or right. Every frame he's choosing one. 50-50. Barely moving. That's what we'd expect. So that worked great. Now I will say that this is a beta, and so sometimes you're going to get errors that are confusing. So what I found is this class whatever hides a global class script. It happens when you've named the class and you're editing it while the game is playing. It shouldn't error out like that, but I have found that it can affect things a little bit. But you can get rid of it by just stopping, exiting the project, and just starting it again, which is a little bit of a pain. But I mean, these are bugs that will, I'm sure, get worked out. Anyway, so how can we make this a little more interesting? Well, how about if it goes in 4 directions at once? So you can click the script here to get back to the script. You can also click the script button up here. 2D script. So that's fancy. All right. So now I want it to go up, down, left, or right. So now we basically just do this, but with the Y coordinate, right? So 4. And also feel free to stop the video and see if you can figure it out for yourself ahead of time. I think that's a super helpful thing to do. And I'll probably try to include some kind of notation or break of this is a good time to stop and see if you can figure out how to do the next part. But for now, let's just keep trucking. So now we need 4 choices, up, down, left, or right. So that's going to return 0 to 3. And then we can just kind of keep building this if statement. Else choice equals 2. Now we want to move up. So up is going to be y, position.y, equals position.y. And in Godot, up is, contrary to what you might think, negative. So that is up. And that's down. You can run it. And look, now he's really jiggling now. Let's change a couple things. First of all, let's clean this up because this kind of sucks to type over and over. So if you want to do it a little more, you can get rid of all this and you can use minus equal. And that will set a variable to itself minus whatever is on the right side. You can do that for all of these. Cool. So that looks a little bit better. That's nice. What if we want it to move more than 1? Well, that's pretty easy. Come up here, var speed. And another shortcut in Godot is if it's very obvious what the type is going to be. So this is going to be a float equals 1.0. This is very obvious that it can only be a float. So you can actually just delete it and do that. Do the little colon equal altogether, and it's still typed. You still get the performance boost, and you don't have to type it. So although you don't have to type it in, it can still make the code. It can make it more or less readable depending on what you're doing. So go ahead and type it in if you feel like you or the editor may not know exactly what you mean. Like if you want to just put a 1 here, well, it's going to think this is an int now. So think this is an integer because it is. But you can put float here manually, and it will now know, oh, this is 1.0. We're just going to do that, though. Save it. And now we can multiply this by speed, or 1 times anything is just itself. So we can just do speed. If we needed to replace 100 of these speeds, we could just highlight it, click search, replace, selection only, and you could find 1, replace it with speed, or whatever you need to do. Unfortunately, I mean, it will also replace this 1, so you have to be careful. Now we have this, and speed, play, and nothing's changed because it's still 1. But see, he's jiggling around. And maybe we want him to go 10 times as fast. So we change it to 10, save. Oh, he's jiggling harder. What if we do 100? Well, then it doesn't, then it needs to be restarted, I guess. Yeah, there. Look at him go. Look at him just go crazy. So it should update while you are running the game. But again, this is beta, so you're going to see some quirks. Maybe you want this to be a little bit cleaner and you don't want to have to edit the code, or you can give it to a designer or something and have them edit it right in the inspector when you click Walker. That's really easy in Godot. You just use this little decoration and you say export above it. And wow, look at there. It's right there. And in theory, again, beta, but in theory, you can change it right in the inspector. And look, there it goes. And that's working a lot more reliably. Okay, let's just click the reset button so it goes back to the default value here. But wait. There are not 4 options now. There's 8. Whoa, right? So then we need to fill this out. This is getting a little cumbersome. This absolutely works, this if-elif thing. But let's look at another little structure that we could use instead. So because everything hinges on this outcome, this variable, and we're just checking to see what it is, well, we can use a switch statement for that. And in Godot, the keyword match is what does it. So we match choice, colon, and now we go through the options. So what's one option? 0. A lot of times for match statements, what I like to do is just put pass on all of these. So those are the 8 options, right? And if you say pass on all of these, then it will stop giving you an error. And I just hate when the screen glows red and there's an error. So the first choice, we're just going to cut that, paste it there. Cut that, paste it there. So every time you have these like colons and it wants to do something, it needs to have something or it's going to error out. Which is why the pass statements can be nice while you're building your code. So what are we going to do for these? Well, they're kind of just a combination of position X plus equal speed, right? Position Y plus equal speed. And then this could be plus minus, so plus plus, plus minus, minus plus, and minus minus. You could do that, but there's an issue with that. So this will be my quick explainer video. If you take a grid and you start at 0, 0, and then on our move right function, we're moving 1 unit to the right, which is going to be 1, 0. And if we move up, we're going to be moving 1 unit up to 0, and in Godot, -1. But if we combine both of those, then we end up moving 1 to the right, 1 up. And what does this look like? That's the actual distance we travel. Well, that sure looks like a right triangle. So, of course, we can find how much this is by using some kind of theorem of some kind. But let me tell you, short answer is that this is longer than 1. And we're going to have to correct for it in the code. So now that we know we've got math kind of working against us right there, let's do a little bit of cleanup here and we'll make it work. And we'll make it work correctly. So first of all, let's define a new variable, var movement. So this is going to be our movement direction, colon equal vector2 dot 0. And vector2 is just like that or that. It is a XY coordinate, basically. That's a vector2. It's 2 numbers in brackets. And dot 0 is a special thing in Godot that just sets it equal to this. Vector2, 0, 0. These are exactly the same thing. This is just a little easier to type and way easier to read. So now we have our movement. So our movement starts off as no movement at all, right? That sounds great. And then we're going to do it here. So what do we want the movement to do? Well, let's just get rid of this for now. And we want the movement to equal, we want it to move left here. And again, this is the exact same as, so let's just set it equal. Right. And here we can go movement, and there's 100 ways to do this. This is just how we're doing it. Movement equals vector 2 dot left. So let's go northeast, right? So we're going to go up plus vector 2 dot right. And then we're just going to keep going. So this is a lot easier way to think about it than just in the math, right? So now we're going to go down plus, and as you can see, I'm just making my way around clockwise. Bam. So we've left out our speed, but this is going to give us the direction of movement, right? Oh, he doesn't move. Why? Well, we haven't edited that position yet. So after that, you got to tab all the way back out to where it matches this line. So we're out of the match statement now, and we want to go position plus equal movement, right? And we save it. Oh, look at him go. Look at our little Jiggle Billy go. So proud of him. So now we're doing that every frame. Okay, so that's great. And you could go movement times speed, right? Well, our speed's just 1. But remember, click on Walker, change this in the inspector, and there it goes. Now it's just like it was before, right? Oh no. What about these? So how do we fix the problem of this being 1.4 times as long? And you can see the problem right here. So print lets us print things to this console down here. Print movement dot length, enter. So obviously we need the brackets on there. So this is a function that all vectors have, and it gives you the length of the vector. So how long it is, how the magnitude of it, right? And ideally, we just want a magnitude of 1. So you play this, and as you can see, when we're hitting up, down, left, right, we're getting 1. And we're hitting the diagonals, we're actually getting 1.4142, blah, blah, blah. Which is not what we want. So this is that's gonna be right here, right? And that times speed. So you're gonna go 41% faster on the diagonal. You may have actually played games, especially old games, that this happens, where maybe a shooter, but if you go in the diagonal, you actually move faster. So you end up doing weird strafe moves or whatever. And it's because of this. We can fix this though. All we need to do, super easy in Godot, movement dot normalized. And now if we look at the normalized vector, it gives us 1 every time, or I mean, close enough to 1 that it's not going to matter. What does normalized do? It keeps the vector facing the same direction, but makes it to 1 unit. It gives you a 1 back for the length, basically. This is extremely useful, and you can, of course, do this in math, but it involves taking square roots and doing some crazy stuff. Just way easier to do in Godot. You just say normalized, and you're good to go. All we have to do is say movement, and we just want the direction out of there. We don't want the magnitude, so we normalize it. Times speed, and now we are good to go. Our guy is going the same speed no matter which way he goes. So the next thing we're going to do is not in the book, but it is to connect this walker to a button. Let's go back to 2D. Let's add a button we can click instead of it going every single frame. So we have some control. Of course, that button you could wire it to input buttons on your keyboard and make a character controller, but for now, we're just going to add child node, and Godot is super simple. So you just say button. Now we have a button. I'm going to click it, click the move tool, move it down here. So it's kind of in the middle of the screen. I'm going to say coin flip, or I'm going to say jiggle. And you can resize it. So this is kind of a rough and dirty button. This kind of looks terrible, right? We want it to be bigger. So you can change the font, and you can change the font size. Theme overrides, font size. Click the check. And now look, 5 is not what we want. How about 50? Let's make this a little more generic, because we might use this button for other stuff. So we'll just tell them to move. So right now it doesn't do anything. There's 2 ways to connect this button to this guy. The easy way is if they're both in the same scene, you can click the button. You can click node. Here are all these signals, all the things the node can interact with. We've got button pressed here. We can double click it, connect it to Walker, makes a new function and connects it on button pressed. And then you just change this from that to step. And let's delete it out of process. We'll just put it back to pass. When we run it, see, this works. It moves 1 speed in a random direction every time you click. Okay, so what's the other way to do it? Well, let's get rid of this. The other way to do it is in code. So we need a way to grab the button. If this was a child, we could do this little thing, var button, and use the name. And this is just the name of it. But this only works on children of this Walker. So it has to be indented in this screen tree. So it's not going to work for this, because it's not going to be able to find a button, because the button's outside. See, it's a sibling of the Walker. So what can we do? Well, there's another thing we can do. If it's going to be in the same tree, which right now it is, we can say button is a button. And we can go export. So you can see it in the tree. Inspector. And now we have our speed that's exported. We also have a button, property button. You click this, it shows you the current scene. Click button, bam. Now it's connected. Now it knows about this button. I'm actually going to go back to the button, click node. Down here, disconnect, just to clean it up a little bit so it's not just sending it to nothing. Okay, so now we're back on the Walker. Walker script. We know about a button, and in one time, we're going to connect the button signal to the step. So how do we do that? Button dot, and then this is a little different, although you can still do it like in Godot 3. This is a little different. So let's do it this way. Dot press. So we're going to use one of those signals. So when you click dot on it, it knows it's a button. And see, it shows you the signals here. A little signal icon. It also shows you the functions and methods it has in there. But let's just tab down with your arrow keys, or you can click it, double click it, or you can just type pressed, whatever. Dot connect. And again, I love the autofill. You click enter and it autofills the brackets for you and everything. It tells you what you need to put in here. So callable is a function. So step. And that's all we need. We don't need any optional flags. So now when you play, same thing. Bam. So we're going to do one more thing in this, which is to smooth out the movement. Because as you can see, it's kind of jerky. I change this to 100. I mean, he's just really going. He's just teleporting. Oh, but we want him to move. We don't want him to teleport. So that's pretty easy in Godot. It's called using a tween. So what do we do with that? Down here or up here, wherever you want. I tend to like to define all my variables in the function at the very beginning, but you make it in the function you need it. I'll say tween, colon equals, new, no, create tween. And now we can use this to move this over time. It does all the in between, hence the name frames. So how do we use it? We say tween dot, And there's a bunch of things it can do, right? Kill, parallel that. So, feel free to control click and look through it and see what it can do. But for now, we're going to tween property. The object is self because it's this object. The property is going to be a text in quotes position. And the initial value, you can change this, but the initial value by default is the current value of whatever position is. And that's exactly what we want. So we don't need to do anything there. We just need to put in the final value. Well, the final value is position plus this, right? So the final value is that. Cut, paste, comma. Of course, you could set this equal to a variable and make it a little bit cleaner. It's probably the right thing to do. And then how long? I want him to be pretty snappy. So I'm going to do 0.25. This is in seconds. You could do 5. You could do whatever you want here. That's how long the tween is going to take. And you're good to go. Look at this. That's how easy it is to make. Now it's animated. Wow. So now you're an animator as well. So you could take this and maybe do some other stuff. You could maybe see what's happening here and then set it up, set another button, connect it to maybe just move left. So then, you're almost making a controller. So func move left. Let's just do this for an example, and then you can play around with it on your own. How do you move left? Well, you could kind of just do it however you want, but if we're doing it like this, then we're not doing a random choice, but we are doing a movement direction, right? But then the movement's always going to be left because that's what we want. So let's just set it here. So move left. We're going to do a tween again because we still want it to be smooth. Might as well just do it right there. And then I'm just going to copy this too. Now, I will say if you're copying and pasting a lot of code, that usually is a good indication that you can be making a function that does the same thing. But I will leave that up to you. So we don't even really need movement.normalize because it's just going left. In fact, we could just put the left here because it's left is already normalized. So you clean this up a little bit. So, there you go. Then maybe we make a new button. See, it auto names a button too. Left button. Left. I'm going to change the font again to 50. Go back to 2D. Put that guy there. Right, he's not connected. Well, I'm going to use the in editor. So this way to connect things could be really useful if you're connecting like a lot of buttons or something like that, because it cleans up your code. You don't have to see all those connections. So here I can just do press. We're going to use the other way to connect. And the method you want to call is move left, move left. I think that's what I named it. Yeah, and see, because that already exists, it doesn't make a new one. It just, bam, connects it. He always moves left. So you could do this to make a character controller with buttons. Go ahead and play around with it. And in the next one, we will look into different kinds of pseudo randomness and do some spicy stuff with, Perlin noise or open simplex noise, which is what Godot uses